Hey everyone, welcome back. We are learning about semiconductors. In the previous lesson, we saw about two-terminal semiconductor devices, in which we saw about a diode, which is a combination of a p-type and n-type semiconductor. We also saw what is forward bias. So in this lesson, I'm going to walk you through reverse bias and the different types of diodes. So what is a reverse bias? We reverse bias the diode with the help of a battery. We connect the negative terminal of the battery with a positive p-type and we connect the positive terminal of the battery with a negative n-type. Because opposite charges attract each other, the holes which are positively charged gets accumulated at the end of the p-type due to this negative terminal over here. Similarly, the electrons get accumulated at the n-type due to the positive terminal over here. Due to this, the width of the depletion region increases significantly. Now, because the depletion region increases, it's hard for the current to flow because there's no movement of charge carriers to make current flow possible. However, above a particular point, there is a leakage current in reverse bias. So when you keep increasing the reverse bias voltage, it overheats and fails due to avalanche effect. Avalanche effect is caused when you keep increasing the voltage. Over here. So due to thermal effect, the electrons and holes gain energy and they start to move around the diode. Once they start to move with high energy, they also tend to collide with each other, forming electron-hole pairs. Now, when there's more electron-hole pairs, there's also significantly more amount of charge carriers that's able to flow and cross this depletion region. So, thus, even a non-conductor or a semiconductor in the non-conduction region is able to conduct energy about this breakdown voltage. Now, this is called this avalanche effect. So, this region about which the diode starts conducting current in reverse bias is known as the reverse bias voltage. Moving on, we're going to see about the different types of diode. So these are some of the examples of different types of diode. We have the p-n junction diode, which we have already seen. It's nothing but a combination of a p-type and n-type semiconductor. And we will be seeing about Zener diode, Schottky diode, tunnel diode, photodiode, and light-emitting diodes in the later part of this course. Most of them have a confusion between photodiode and LED, but there's significantly different ones, which we will be seeing later. Now, we will see what's a Zener diode. Zener diode is also called as a breakdown diode because this diode is especially designed to work in reverse bias condition. Because it works in reverse bias condition, they have low and specified reverse breakdown voltage. Now this is a symbol of a Zener diode. Do you remember the symbol of the p-n junction diode? It had the same anode, but the cathode was just a straight line, but in a Zener diode we have this extra projection. Now, the cathode becomes more positive than the anode once the reverse voltage reaches the predetermined value. So, remember we saw something about the avalanche effect. So, Zener diode also conducts current because of avalanche effect. Guess why? Because Zener diode acts in a reverse bias condition. So this is the voltage current graph of a Zener diode. And the reverse saturation current is mainly because of the minority charge carriers in the Zener diode. The symbol of the Zener diode is this, but it is also represented in this form. Now, as we saw above, due to the increase in the depletion region, the current flows initially very hard until it reaches the breakdown point called as the Zener voltage, above which even a semiconductor in a non-conduction region is able to conduct electricity significantly. So now this region is called as the Zener breakdown region. Now this is the minimum Zener current, and similarly this is the maximum Zener current that a Zener diode can conduct. Now let's see the applications of a Zener diode. We all know about the Bluetooth technology. In order to have Bluetooth possible, we need to provide 3 voltage, and this is done by Zener diode. So you have 6 terminals where you ground 2 terminals and provide a 3 voltage reference to the Bluetooth device. A Zener diode is also used as a voltage regulator. So let me zoom in for you to explain how Zener diode helps in voltage regulations. So this capacitor over here filters the AC voltage of 230 volts. Now once this is being filtered, this diode then rectifies the AC voltage. A rectifier converts an AC to DC current. Now what does a Zener diode do? Now it takes this rectified DC current and regulates it to a constant 15 voltage, which could be used for various applications like even control of switching of light, as in the automated lighting control systems. Now next we're going to see about the Schottky diode. Schottky diode was found by a German physicist called as Walter Head Schottky. So now you can see the relation how the Schottky diode got the name Schottky. Now this diode is also called as the Schottky barrier or the hot carrier diode. Usually diodes are a combination of p-type and n-type, but this diode is a combination of a metal and a semiconductor. So you see this is a symbol of a Schottky diode, where this is the cathode and this is the anode. So we don't have a p-type and n-type, instead we have a metal and an n-type or n-type semiconductor. So take a look at this picture. This is how a Schottky diode looks like within. So this is the metal layer, and we also have silicon dioxide and guard rings to protect, and this is the epoxy layer, and this is the semiconductor, that is the N plus substrate, and at the end we also have a back contact metal for further protection. So now Schottky diode works at a lower voltage drop, about 0.15 to 0.45 voltage. It has a higher switching speed and efficiency because it's a combination of metal and a semiconductor. Here, the N-type semiconductor acts as the cathode, while the metal acts as the anode instead of a P-type semiconductor. The conduction is from the metal to the semiconductor. Now let's see the features of the Schottky diode. It has a higher efficiency, a low forward voltage drop, and low capacitance. All this is because it's a combination of metal and a semiconductor. You know what's capacitance, right? The ability to store charge. It also has an integrated guard ring. Now this guard ring helps in stress protection. Let's also see the applications of a Schottky diode. A Schottky diode has high current density since it can conduct more electricity because it's a combination of metal and a semiconductor. So it's used in high voltage clamping. Now clamping is nothing but you hold the voltage and you limit the current flow. You also use it to prevent the transistor saturation. Transistor is a 3-terminal semiconductor device, which we'll be learning in the later part of this course. A Schottky diode also has a standalone photovoltaic system, and so it's used to prevent batteries from discharging. So if you can prevent batteries from discharging, where do you think it can be used? It can be used in solar panels at night so that the batteries don't emit radiations during night, like in the grid systems. It's also used as rectifiers in power supplies. Rectifiers can rectify the current that is from AC to DC or DC to AC and since we've come to the end of this lesson, let's sum up of what we've seen in this video so far. We saw about reverse bias voltage, what is it and how does it work. We also saw different types of diode like the PN junction diode, the Schottky diode and Zener diode. We saw their applications, their working and their features. In the consequent lessons, we'll be learning about the other types of diodes like the LED, photodiode and tunnel diode. So thank you for watching and stay tuned for more. If you have any queries, please ask me in the comment section below.